Right, Sani Bonani Bungani, good day, I'm Mr. Simons. Now I'm looking at one of your definite questions we test in exam, where you can add and subtract exponents when they're separated by a plus or minus sign. Right, so when adding and subtracting exponents, right, we generally require to split and factorize them by taking out a common factor. The split is not compulsory. But I've learned over years teaching, if I don't show you how to split, you'll end up writing things wrong. So look here at problem number 1. I have 2 to the power x plus 2 minus 2 to the power x plus 1. Alright? It should be clear to you what is a common factor. 2 to the power x there, 2 to the power x. Problem is, once we take that out, the error persists with learners where you write 2 minus 1 instead of 2 to the power 2 minus 2 to the power 1. So therefore I introduce this concept, something that old textbooks teach you and so on, split. Right? So if I split that, remember first law, I can break that up. When do I add exponents? When I multiply and the bases are the same. So that becomes 2 to the power x times 2 to the power 2 minus 2 to the power x times 2 to the power 1. Now because they are separated by a minus or plus sign, we always look for a common factor first. First rule of factorization. So if I factorize, if I take 2 to the power x out, I'm left with 2 to the power 2 minus 2 to the power 1. So I hope you take note of that step, because I'm tired of marking where learners go write 2 minus 1 instead of 2 to the power 2 minus 2 to the power 1. So 2 squared gives me 4, 2 to the power 1, 2. So 4 minus 2 gives me 2, and my final answer simply 2 to the power x times 2 to the power 2. So there I've simplified it as far as I can. Right, now let's look at a more complex problem, number 2. Right, so example number 2, they say simplify. Give me 2 to the power 2 and outside x minus 3 times 2 to the power 2x minus 2 divided by 3 times 2 to the power 2 raised to the exponent x minus 1. Right, so here applying law 3, 2 times x gives me 2x. That there simply stays as appears. In the bottom, 2 times x become 2x, and 2 times minus 1, negative 2. So on the top there, I assume you can see 2 to the power 2x and 2 to the power 2x take out as a common factor. Anything divided by itself, 2 to the power 2x divided by 2 to the power 2x gives me 1. Negative sign I keep. If I take out 2 to the power 2x, please, I'm still left with 2 to the power negative 2, and the 3 simply stays. Right, at the bottom, if I split, it's 2 to the power 2x times 2 to the negative 2. Right? Now, we must now simplify the bracket. So I have 1 minus 3 to negative 2 is 2 to the power 2 if I take it to the bottom. 2 negative 2 there would become 1 over 2 squared, which is 1 over 4. Right? Now, the objective when you give you this problem is the common factor in a fraction will always cancel top and bottom. So see, if I take that out, I'm left with 1 minus 3 over 4, which gives me a quarter on top. The bottom I have 3 times a quarter, which means 3 times 1 over 4, which is 3 over 4. So that's how I get a quarter divided by 3 over 4. Change division to multiplication, and we'll always invert or swap around the fraction at the bottom. Write down its reciprocal. So 1 over 4 times 4 over 3. 1 times 4. 4 times 3 is 12. Or 4 and 4 cancel, and I'm left with 1 over 3. 4 over 12 is also 1 over 3. Right, so if you're enjoying the lesson so far and you're understanding, please subscribe, like it if you want to, and share. Problem number 3. Now I've given you 3 2k plus 1 minus 3 2k minus 2 divided by 32k minus 2 plus 32k minus t. Right, so if I split, I have 32k times 3 to the power 1 minus 32k times 3 to the negative 2. Bottom, 3 to the power 2k times 3 to the negative 2 plus 3 to the power 2k times 3 to the negative 2. So in blue, you should see the common factor on either side of the minus sign and plus sign. So if I take that out, I'm dividing by it. No? So I'm left with 3 to the power 1, which is simply 3, minus 3 to the negative 2. The bottom, if I take out 3 2k, I'm left with 3 negative 2 plus 3 to the negative 2. Again, as I said, the objective is always to ensure that these common factors cancel. Right, so most of our exam questions, they always cancel, and we just solve the values that's given after that. So that becomes 3 minus 1 over 3 squared, which is 1 over 9. 3 negative 2, 1 over 3 squared, which is 1 over 9, plus 3 negative 2, which become 1 over 3 squared, which is 1 over 9. 3 minus 1 over 9, right? 3 there's 27 over 9 minus 1 would give me 26 over 9. But you have a calculator, so punch it in and you'll get that answer. 1 plus 1, when I add two fractions and the denominators are the same, 1 plus 1 gives me 2 over 9. Change division to multiplication because I have two fractions. So 26 over 9 times, what happens to the bottom fraction? They change places. 9 went top and 2 went bottom. So 9 and 9 cancel, and I'm left with 26 on top, 2 at the bottom. 26 divided by 2 equal 13. So I know you're enjoying the lesson so far. Please pause, redo the problems, see where you make errors, redo it again till you don't make the error. Sooner you get used to it, the better off you are ensuring you're getting this 4 to 5 marks in exams when you have to add and subtract